before we jump into the example then, let's take a look at the question that you wrote down. So basically we've got two equations, x equals vt and y equals y original plus v original t plus 1/2 at squared. How are these two equations connected? Time, exactly. If you find time using one of them, you can use that time and put it in the other. That's how these two equations are connected. Otherwise, though, they are very, very different. Because this is a horizontal equation, that means this is a horizontal velocity. This is a vertical equation on account of the acceleration. So that is a vertical velocity. So they are two different velocities there. We have to make sure we're very careful with that. So if I want to figure out how fast this object is going after it leaves the table, or as it's leaving the table, I need to find a couple pieces of information. And I'll just put in the ones that I measured. I found the height to be about 0.92 meters. And when I did the distance, I got about 1.49 for the distance. And those are both going to be in meters. The reason that you need those numbers in meters is because when you're running your calculations, this acceleration here and here and here, that's in meters per second squared. So in terms of length, we have to be consistent with those units. So if I want to solve for velocity, is this a horizontal or vertical velocity? Horizontal, because I'm wondering how fast it's rolling horizontally off the table. Which of these equations is a horizontal equation? Yeah, just the top one, because this one has the x in it. Any equation that has an acceleration will be a vertical equation, because that acceleration is what occurs when gravity is pulling the object vertically. So, this is the equation I want to look at in order to figure this out. So x equals vt, so if I want to solve for v, v would be equal to x over t. And hey, I know what my distance is. I measured it to be 1.49. Yours might be a little bit different, and that's okay. Divided by time, and oh dear, I don't have time. But if I can find time, then I can finish this problem. So the way that you solve for time is by using one of these three equations here. Because if this object is just rolling off the table, we can use that to figure out how long it took to hit the ground. This equation is not going to work, no matter what, because there's no time in it anywhere. So we're down to these two. This equation has time, which is nice, and it has acceleration, that's good. But we don't know the vertical velocities, especially, well, we know this one actually, we'll get to that. We don't know the final vertical velocity, though. We don't know how fast it's going down when it hits the ground. So there's two unknowns in this equation, so that doesn't work. So let's take a look at the y equation. Now, I know my impact spot. So what is my final height equal to?
0.
Yep. And that makes my original height equal to whatever the height of the table was. I measured it to be 0.92. What is this velocity? 0. Isn't it rolling off the table with a velocity? Exactly. So even though it's rolling off the table with a velocity, that is a horizontal velocity. This is a vertical equation, so this means we're wondering what the original vertical velocity is. And if it's just moving horizontally, it's not originally going down or up, then that original vertical velocity is 0. Then we've got 1/2 at squared. A is negative 9.8, and t squared. So we got to solve for t in this equation. So I'll move this over there. Negative 0.92. 1/2 times negative 9.8 is negative 4.9. So to solve for t then, we're going to divide both sides by negative 4.9. And the negatives cancel each other out. So let's see, what does that come to? I got 0.188. So my time squared is 0.188. And of course, I want this time to be regular, so I got to take the square root of that. So the square root of 0.188 is 0.433. And now I have my time. So all I do is I take that time and I put it in its place right there in the denominator. So to figure out my velocity, I just do the math. 1.49 divided by 0.433, and I get 3.44 meters per second. As the velocity. Props to Sarah's group. They got it pretty much right on the money. They guessed 3.5 meters per second. So good work on that. Again, this is all about getting the practice in, and the more we go over these problems and the more you do them on the homework, the more comfortable you're going to get using those equations. But the main thing I want you to leave the class with today is, anytime you've got an acceleration in your equation, that means it's vertical. And not just the acceleration is vertical, but everything inside of it is vertical. This would be a final vertical velocity, original vertical velocity, final vertical velocity, original vertical velocity, vertical acceleration, and on down the line. So you got to make sure you keep those vertical and horizontal numbers straight. Questions on any of this? Awesome. Go ahead and work on worksheet number 2. That's due tomorrow.